Okay, welcome back. So I'm going to quickly show you a very simple model of technology adoption. Let me share the screen now. Okay, so when I say technology adoption, this is sometimes called technology transfer, and sometimes it is called imitation. Okay, so here the notion is this. So there is a firm, a sector, or a country that is already innovative. Okay, suppose that they innovate continuously, right? Then you adopt this in your own firm. So there are leaders and followers. Okay, so another firm, another sector, another country could be the follower. Okay, and there are nice mathematical models and historical narratives as well. So one important guy is actually Alexander Gerschenkron. Alexander Gerschenkron. Another nice study, so this is, I guess, 1952 or 62, okay? There is a nice paper by Richard Nelson and Edmund Phelps. This is 1966. And there are many others. So there's one paper by Moses Abramovitz. This one is 1985, I suppose. So there are many things. Maybe I can share a list of these with you. So the idea is this. Oh, this literature is also sometimes called catching up literature. Okay, so catching up models. So what we observe is something like this. So if you look at the data, remember that we discussed a data set where there are some countries here. So this was the average growth rate from, let's say, 80 to 2000. So let me be more specific. So this would be the average growth rate of economies from 1980 to 2010, let's say, okay? And that would be the GDP, so these are country level. So this would be the GDP at 1980, okay? So there are countries here, these are miraculous growth countries. There are some countries here, and there are many countries here. I think we discussed this in the first week when we talk about divergence across countries, divergence of communities. Now, some of these high growth, so if you look at this part of the figure, if you look at these countries, okay, these would be the leaders, right? Why leaders? Because they are already rich in 1980. And those would be followers. Why? Because they were poor in 1980, but from 1980 to 2010, they grow at the fastest levels. So if you look at the time series of this, if this is time, if this is 1980, if this is 2010, some economies, the leaders, would be growing like this, okay, these are leaders, and followers would be growing something like this. Okay, so if this is, let's say, GDP. Okay, so that's the idea. So they catch up. Leaders are on the front already in terms of technologies and in terms of capital stocks and in terms of GDP per worker, let's say. And follower countries adopt new technologies from the leader firms, leader sectors, leader countries. And eventually, in time, of course, that translates into productivity growth, and productivity growth translates into higher rates of economic growth. Okay. Now, if you look at a real figure like this, you're gonna find countries such as South Korea, Japan, Taiwan, Singapore, and some others here. Sometimes these are called Asian tigers, as you know. In most cases, especially in South Korea, as we discussed before, government involvement is important, especially for coordinating the private sector behavior in terms of industrial policy and technology policy. Okay, and that, of course, was due to a highly authoritarian government of South Korea, and the same is true for Singapore, actually. But Singapore is a very small country, so maybe it is not really a nice way to compare. Maybe it's not a very good example for to be used in comparisons, international country comparisons. But we observe such follower countries, and sometimes we call them miracles. Okay. Now let me show you the simple mathematical argument of this. Okay. Now we are interested in understanding how productivity in country I change in time. Okay, and the general model we have will be like this. So there will be, of course, the country's own effect, right? Because this is a differential equation. Most of the time, the existing productivity level is important, and I will show you why. There is also the leader country. Okay, let's denote this country by okay, let's denote this country by F for no, not F. Let's denote it country by 0. Okay, so this is the, so I is the follower country, and 0 is the leader country, or frontier country. And there could be, of course, other stuff, right? There are some effects that depend only on time for all countries, and some effects, let's say some of the effects depend only on time, some of the effects depend only on country, and perhaps there could be other stuff. Okay, such as, for instance, human capital. Okay. Now, why these two are important? The idea is this: if a country is far away from the frontier, in the sense that this difference is too large, okay, then the theory suggests that this country will have the advantage of backwardness. Okay, why? Because in some cases, for instance, they do not have to spend so much money on basic research, right? It is already there. The technology is already there. The most difficult part is already achieved by the leaders. So there is usually an advantage of being backward in terms of technology. Okay? So you can do something like this. The growth rate itself in country I will be positively changing with human capital in that country, because if people are more skillful, they can more easily adopt foreign technologies, right? If people are already familiar with certain technologies because they went to better schools, they learned foreign languages and all this stuff, they can more easily transmit foreign technologies to the domestic economy. There is also this difference. Let's say this term. Now, what does the theory tell us? The advantage of backwardness tells us that this term must have what? A positive effect, right? If the distance to the frontier is larger, oops, sorry. If the distance to the frontier is larger, then productivity growth rate in the follower country must be larger. And also, again, oops, there could be some country-dependent factors, such as beta I. The policy environment in the country. There could be many stuff in beta I. And again, in fact, you can write, there's global conditions, a set of global conditions that affect all countries' performance in technology adoption. Okay? Global, for instance, global status of intellectual property rights, or some other economic or scientific or technological or social effects, such as COVID-19, for instance, right? So we will see perhaps some effects of COVID-19 on technology adoption by countries. So once we start imagining in these terms, we can of course write something like that, okay? So suppose that this is the growth rate, again, right? This is the productivity growth rate in country I, and I said that it is depending on some country specific factors, okay? Some time specific factors, such as that these are just numbers, and it depends on human capital, all right? Suppose that there is this function, it is depending on human capital. Maybe I can just write it. So it depends on human capital in the country, and also this term. Let's say the parameter would be here, lambda, right? So with theta greater than 0 and lambda greater than 0, you write, so this is basically Nelson and Phelps, okay? Now you can ask, of course, okay, suppose that this is exogenous for simplicity, right? You can still need to know how does this change, okay? Now go back to a couple of weeks before and remember our simplest model of innovation. In that simplest model of innovation, what we found was growth could be sustained at a fixed rate, right? Remember that model? So here in this model, in this technology, so this is a technology adoption model, right? This is a technology adoption model. So here we simply assume that, okay, the innovator country keeps innovating. Okay, now we have less than a minute. Let's meet at 3:50, okay? At 3:50, after about 15 minutes, to conclude our meeting. All right? See you later at 3:50 p.m.